As I said, we're going to do a couple of interpolation questions first, then we'll get stuck into laws of logarithms. Interpolation is a fancy word for saying that we're going to estimate where a value is, basically. All right. We're going to use what we know about the class widths. We're going to use what we know about frequencies to, in this case, estimate where, what the median is. Now, at GCSE, as far as you went with estimating any median, was you were asked which group it was going to be in, and that was it. All right? They basically just said, tell me the class in which the median lies. And what you would do is you would find the sum of all the frequencies, which in this case is what? 60. So you'd add up the frequencies, and then where would the median be if there's 60 in total? The 30th value, right? The 30th value. And all we'd try and do is find where the 30th value would be by doing cumulative frequency. Yeah. So the cumulative frequency, if we added it in, 7, 17, 32, 51, and then 60. Where's the 30th value? It's in that group there. So that's as far as GCSE goes, okay? The step we want you to take on top of that is actually to give us an estimate for what that median might be. So we know that the median is going to be somewhere between 160 and 170, right? We know it. And what we're going to assume here, and you might be asked this, we're going to assume that all of the numbers, all of these 15 values between 160 and 170 are evenly distributed between 160 and 170. Because let's face it, they could all be 161, or they could all be 169.5, right? So we're going to assume that they're evenly distributed throughout it, and that means that we can use this interpolation to help us find it. Now the calculation is as follows. It's a proportion calculation, and it is drawing the line. It's the line that I draw. And I think the learning pack does it one way. I might do it a slightly different way, and other people might do it a slightly different way again, but it's the same calculation. All right, so here's how I set it up. I'm going to draw a line, and this line represents this group here, the 160 to 170 group. All right, that's where it represents. So at the beginning of the line on the top, I'm literally going to write 160. And at the end of the line on the top, I'm literally going to write 170. And somewhere in here, it doesn't have to be in the middle, but somewhere in there is the median, which I'm going to call Q2, just because median and quartiles you're going to be asked quite a lot about, right? So Q2 is the second quartile, it's the median. So all that line is saying at the minute is Q2 is somewhere between 160 and 170, yeah? Now the other aspect that I'm going to use about this data on the other side of the line is cumulative frequency. Now, I want to know what the cumulative frequency is when we got to the 160 value. So the cumulative frequency so far, when we get to 160, is 17. Yeah? There have been 17 pieces of data counted, collected, before we got to the class that starts at 160. So 17 is my current cumulative frequency. Cumulative, at the 170, we want to know how many data points or values we've had by the end of that group, 160 to 170. So by the end of that group, we've had another 15 added on, and so our cumulative frequency is 32. Now, somewhere in between the 17th value and the 32nd value is our median, which is at the 30th value. All right? Straightforward. Now, just looking at that line, if we're looking at the 30th value, the upper limit here is the 32nd, and it starts at the 17th. Do you think the median is going to be closer to 160 or 170? 170, right? Because 30 is closer to 32 than it is to 17, so we're thinking the median is probably going to be closer to 170. Now, once you've got that line set up, it's all about a proportion calculation. And this is where you might see it done one way, you might see it done another way, but the calculation is basically the same. So what I'm going to say is I'm going to concentrate on the top half of the line first, and I'm going to say if I divide the distance between Q2 and 160, if I divide that distance by the whole distance from 160 to 170, all right, so this proportion of this group, that's going to be equal to the proportions on the other side of the line. is going to be equal to 30 minus 17. Okay, because 30 minus 17 is exactly the same as Q2 minus 160, or not the same value, but the same proportion. And that's going to be divided by 32 minus 17. Okay, so this bit out of this bit is going to be the same proportion as this bit out of this bit. And what you've actually done there is you've created an equation that only has one unknown, Q2. So all we've got to do is simplify and solve. So the next line would be Q2 minus 160 divided by, well, 170 minus 160 is 10, equals 30 minus 17, which is 13, over 32 minus 17, which is 15. Then, simplify down again, Q2 minus 160 is 10 lots of 13 over 15. And then Q2 is going to be 10 lots of 13 over 15 plus 160. Now, somebody work that out for me, and let's get a couple of different people. You got it already? 168.7 centimeters. Can I get anybody else with a corroboration? Back him up on that? Yeah, we happy with that? Okay, cool. So that's our estimate for the median, and importantly, and I'm glad Seb said it, you need to include your units. All right? If you miss out your units, you may well drop a mark. You don't want to be dropping marks. So that's our estimate. That's it. Okay, we can use the same process to find the quartiles, and once we've got the quartiles, we can find the interquartile range. It's identical. All right? Do you want a question to practice on that that's exactly the same, or do you want me to show you one that is very slightly different and what you've got to watch out for? Hands up if you want to just practice one that's identical. That's boring. Fine. Okay, so the reason I said that the other example is very slightly different, what you've got here is like the dream frequency table, because your groups overlap. So if I said to you, where does the number 160 go? Which group does it go into? You might think, well, does it go into this one, or does it go into this one? Because 160 is in both groups, isn't it? But you've got inequalities, right? The inequalities mean if you had exactly 160, it goes in this group, because h less than or equal to 160 is in this group. This group starts at h greater than 160, right? So 160 wouldn't qualify. What you've got to watch out for is this question that was in assignment 8, right, which somebody asked me about today, and it's a good example of something slightly different. What's the difference when you look at groups this time? Well, that's exactly right. That's how we fix it. But the difference is there's a gap between the end of one group and the beginning of the other, right? They don't overlap. So what we've got is 29 here and 30 here. So we need to use upper and lower bounds. All right, that's the only difference. And I would say if you're confronted with a grouped frequency table, the first thing you're going to want to actually find out is, do the classes overlap or are there gaps between them? That you just got to get that first. And if you establish that first, you're not going to get into trouble. So how does it affect it? Well, not by much really. We still need to know the total frequency. All right, what's the total frequency in this one? I think it's 80, right? That's it. Yeah. It's worth writing in your cumulative frequency. Just because it's a useful thing when you're trying to identify where medians and quartiles and stuff actually are. We're using interpolation to estimate interquartile range. So, I mean, do the question by all means. You don't have to listen to me prattling on about it. I'm going to do Q1, and then I'm going to lead you through it anyway, and then show you the answer at the end, right? So, Q1, which is the lower quartile, we find, well, we need to know which position it's in. If there are 80 pieces of data, all we're going to do to find the lower quartile is divide that by 4. So it's in the 20th position. Now, I'll come back to why we just divide it by 4 and we don't worry about going in between one value and the next. I'll do that at the very end. Okay. So it's in the 20th position. Where is the 20th value? Well, there's up to the 5th, there's up to the 15th. So the 20th position is going to be in this group here, 40 to 49. So we just set up the calculation. Draw the line. There it is. Q1 is going to be in there somewhere. It's going to be between 40 and 49. But as Seb said, we need to go 39.5 and 49.5 to allow for the fact that those groups don't overlap. It's just your upper and lower bounds. What's the cumulative frequency as we go into that group? It's 15. What's the cumulative frequency as we come out the end of that group? It's 51. And we know that the lower quartile is in the 20th position. Little bit of a prediction then. Is it going to be closer to 39.5 or 49.5? It's going to be closer to 39.5, isn't it? Because 20 is closer to 15 than it is to 51. And that's just that's something that you can use to check your answer effectively, because it's difficult to check that you got the right answer in a calculation like this. So the calculation is the way I do it. I'm going to do Q1 minus 39.5 divided by 49.5 minus 39.5. And that's going to be equal to 20 minus 15 over 51 minus 15. Which, as I said, is this out of this divided by this out of this. Okay. Rearrange the formula. So what have we got? So we get 5 out of 36 multiplied by 10, add 39.5. Q1. It's 40.9 and it's minutes. So if you're finding the interquartile range, you've got to find Q3, and then you just do Q3 minus Q1. So I'll let you finish the question. I'll stop talking for a couple of minutes. I'll do the answer, I'll show you the answer, and then we'll get started on logarithms. Okay, so we'll start recording again. So what you've got is Q3 comes in at 54 minutes, which means that the interquartile range is going to be 54 minus 40.9, which does come out as 13.1 minutes. Done. Now, I'll stress again the importance of looking for whether or not the groups overlap. And if they don't overlap, first thing you've got to think, upper and lower bounds. Okay? It catches a lot of people out and you can lose quite a lot of marks from it. In case you're wondering why we just took the 20th position, for example. So if you've got 80 runners and you wanted to find the median, right? So say you had 80 pieces of data and you wanted to find the median. Your median would be halfway between the 40th and the 41st, wouldn't it? That's what you're used to doing. The reason that we don't do that is because this data has been grouped and it's time anyway, but it's being treated as continuous data. And when we use continuous data, we don't need to do halfway between 40th and 41st. We take the 40th, all right? And it's just a subtle difference between how you deal with different types of data. Any questions about interpolation? Brilliant. Right, let's crack on then and actually do some logarithms.